All right, we're looking matrix as transformations. So just make sure we see what's the original because it matters here. Each drawing below represents the result of a transformation that maps the solid square onto the dotted square. So the solid square is the original. That's the original. Dotted square is the image. All right, so which represents this transformation here? Well, sometimes there's some tricks, and the more you do these, the easier they get if you can see any patterns. But I just want to sort of recognize that this is equal to -1 as a scalar of the identity matrix. So what happens when you multiply by -1 an object? All right, well, not really sure. Let's go ahead and we'd have to map it out to see what happens. And it looks like we have some different mappings on each of these. So let's look at the different ones we have. All right, so it looks like we have 3 different situations for our mapping. Is there any point that we can use to see? Yeah, okay. So I'm going to go ahead and try to take a shortcut here, see if that helps. So usually we would do all 4 points to kind of confirm and see what happens. But I'm just kind of noticing each one of these looks like we have a 1, 1 value right here. Like this one right here looks like it's 1, 1. Like that vector right there, that point. So that was pretty ugly arrow vector. So the vector I'm looking at is this vector right here. So that point is 1, 1. And I can call that same point 1, 1. And on the bottom, I can call those points 1, 1 also. So I'll just call that 1, 1. And I'll call that like, this one's just a little bit different. This one looks like a 2, 1. So x is 2, y is, it's not a fraction bar, 2, 1 on that one. All right, so that one's a little bit different, but I think 1, 1 would kind of give us a good idea. It should move it over. So what's happening with each one of these? So if we look at it in terms of geometry, this is a reflection over the y equals x line. So it's a reflection over y equals x. That's what happened there. This one right here is a rotation of 180 degrees. This one is a translation of something on the negative x component. So it moved negative x direction. And this one right here is a dilation of like a half, just in general. All right, so it got smaller. So just kind of recognizing what's happening here and then using a test point to confirm with what's going on here. So if I had to guess, which one do I think it would be? A -1, I feel like it might reflect it over the y equals x line, or it could be the rotate 180 degrees. These are the 2 in the running. Everything got turned to the negative, so all of these are positive. So I'm going to go ahead, and if I had to choose one, I would choose this one right here, because basically all the x, y values are turning all into negative x, negative y values, okay, which is what a rotate of 180 degrees does. All right, but let's go ahead and just confirm it. If nothing happens, that would be this one right here, because the point I chose of 1, 1, if I chose 1, 1, because that's the one I'm going to do first, that's right on the y equals x line, so it would not change if I just wanted to kind of use one position vector to see what happens. All right, so let's go ahead and set it up. So our transformation vector times our, I'll call it just u position vector. So that's going to transform it in some way. So our transition vector is -1, 0, 0, -1. I'll just use this one. Times u. And I'm just going to use this one position vector because I think that's all I should need. And this is a 2 by 2. This is a 2 by 1. So our resulting answer is going to give us a 2 by 1 matrix with its dimensions. All right, let's see. So this equals my 2 rows by 1 column. Now it's just ones and zeros, so I don't like doing stuff in my head too much, but we should be okay with this one. -1 times 1 is -1. 0 times 1 is 0, so that's all we have there. That's it. And then on the bottom, 0 times 1 is 0, -1 times 1 is -1. All right. So what happened here? This point right here turned into this point right here. That's a change in x of -1, change in y of -1. So what happened there is it looks like it rotated all the way around. All right. So we just confirmed it that this point right here, notice this point would land in quadrant 2 here. This point would stay in quadrant 1 but get smaller. This point would land in quadrant 4, which is what happened to us. And this point right here, if we did 1, 1, would stay exactly the same. And then I'd probably just check out what happens if I do 2, 1 as a position vector. Would it land over here if I had an answer that didn't change? But everything looks to be that answer. Yep. So just going back to the original idea of that -1 scalar just negated or made an opposite of all the values from our position. All right. Just see if the next one is anything different. All right, a little bit different. State the matrix that can be used to perform the given transformation. A 2 by 2 transformation that is represented in the drawing below reflects the solid square across the y-axis to make a dotted line. State the matrix that can be used to perform the given transformation. All right, so what transformation matrix times a 1, 1, and then we could list them all out if we wanted, but I'm just going ahead and see if I can't get this point right here to transform to that point right there. So it's a translation of, let's say it would be like a if this is 1, then that would be like a translation of -2 in the x direction. So how does something move in the negative x direction with regards to like a 2 by 2 transformation matrix? The 2 by 2 transformation that is represented, we are dealing with a 2 by 2. So all the x values, the x and y values get moved over -2 spots. Well, if I have a negative out here, that's going to flip it into this quadrant right here. So I need to subtract them. All right. Just going to go ahead and freestyle a little bit. So how I would do this is I don't know what these are. I know it's a 2 by 2, so I'd call that A, B, C, D. I need to know what these values are. And when I multiply it by a 1 by 1 matrix, and I could do more if I wanted, but let's just try to make it easier, I get the value of, now remember, this is our change in x's on top, our change in y. Oh man, what happened there? All right, let's get back over here. There we are. Sorry about that. change colors on me too. Okay. All right. Change in X is on top, change in Y is on bottom, and it gives me a 2x1 matrix, 2 rows, 1 column. And let's see, the change in X right here would be negative, so I'd call that like a -1. And the change in Y value, there is no change in Y value. So let's see, Y would still be 1. Okay, so just to make sure I don't throw anyone off, -X for a change, +1 for a change, that lands right there. So that's exactly what I'm talking about. All right, let's go ahead and show you what I'm. So this is the original vector that we have. That's the 1, 1. And then it converted into this vector right here. Which is basically kind of on the other side. All right, in quadrant 2. All right, not perfect, but in general. All right, so let's go ahead and what I would do is I would multiply all this out and see if I can't solve this in some way or another. This could be a bad trail, but that's fine. It's good to kind of practice. So this is the vector that we're talking about. All right, so this is, let's go ahead and do it. A times 1. A times 1 is A. B plus B, B times 1. And all right, that's all we have on the first. And then C plus D for that one. All right. And then that has to be equal to -1, 1. All right. Well, it looks like I'm going to need more than just this one. I have 2 unknowns, and I have 4 unknowns. I have 2 on top, 2 on the bottom. So A plus B in some way needs to make -1. C plus D in some way needs to make +1. All right, so one of these is -1 basically, and the other one's 0. One of these is 1, and the other one is 0. Okay. So I'm going to go ahead and just test this out. I'm going to try, because we can just experiment. It looks like we're just kind of fiddling with positives and negatives. So let's try the -1, 0, 0, 1 matrix. All right, so we're going to go ahead and try that. That's my side work. All right, so side work. Let's get rid of this. Just have my own section for what I'm trying here. All right, so -1, 0, 0, 1 times 1, 1. All right, see how that works. -1 times 1. So far, so good, is -1. 0, so that zeroes out, so we got that one. And then 0 times 0, 0, yep, so that works. So we got it. So basically my strategy was trying like a generalized field here and seeing how that kind of affected to give us the answer that we were looking for. And then if I needed to, I would go ahead and look at more of these points and get more A's and B's floating around with their answers so that it would narrow in on this. But I prefer kind of a guess and check method so that we can kind of link these in together. So there's my answer. So it looks like there's the answer right there. So we'll try that, -1, 0, 0, 1. So the change in X got to be a negative. So basically that's what's happening. So it's good to kind of analyze what happened here. So the change in X was a negative, and the change in Y, there was no change there. So in this identity matrix, the change in X was negative, so it moved it over into the negative X side. And then the change on Y, there's no change because Y didn't change. So I got -1, 0, 0, 1. Okay, so that worked. Each one of these is a little bit different, and you just kind of have to take what we know about matrices and do our best with it. I'll see if the next one's any different. It's just the pointer. All right, so this is, we just talked about what happens here. So the more you do these, the more you can kind of see patterns. So I'll just talk about the pattern real quick. So the pattern here is the change in X is what's happening. So there's no change. Notice this looks like a identity matrix, except for there's a negative down here. Change on Y, it went opposite. Or negated, so an opposite idea on the Y. What does that mean? X stays the same, Y's turn negative. X stays the same, Y's turn negative. All right, so looking for patterns, and the more you practice, the easier they get. There's not many. It's a matter of just setting it up properly and then just messing around with it to see where it lands.